Ça marche? Can you hear me? Yeah? All right. And I'm going to be with Allan, with our CTO at Stream Data. So, real-time APIs and real-time APIs in fintech. So first, what I want to do is to define what is real-time API, and then real-time in fintech, and then we'll talk about the options for implementing them. The focus here is going to be more on capital markets applications, even though some of it is applicable to retail banking applications too. So why on earth Twitter, Salesforce, and Facebook have launched real-time APIs over the past few years, and why in some cases you guys should think about launching one? It was a scalability issue. Some of these got actually some performance issues because of the time-sensitive nature of their data that they needed to send to many people at the same time. So they started to stream that information. Now, real-time is one of those buzzwords that means very different things for many different people. So what I want to do is to start by defining what is real-time. I'm sure if I ask everybody here in the room, even if it's night time and we're going to talk about dynamic data, so I hope you wake up. Everybody's going to come up with a different definition of what is real-time. And it's actually just because real-time is actually relative to the user. Something that's real-time for a physician is not going to be real-time for a high-frequency trader. So that's a scale of time that I want to define here so that you identify where you fit and what is real-time for you. So in finance, the time horizon starts very fast in nanoseconds with high-frequency trading, whereby you're trying to be faster than the rest of the market. And it ends with Warren Buffett. Warren Buffett, he puts a trade and it's for more than 5 years and pretty much 10 years. So this is real time, and this is the time in finance. In the middle, you have algorithmic trading, which is for servers, whereby the time scale is more in the 100 milliseconds. And then you have retail trading and active traders, who could be professionals or just day traders. So typically, here, what we're going to talk about is for the massive audience, which is pretty much the retail trading population. All right? Can you see? Yeah. So this talk is not about high-frequency trading, even though if you want to talk about high-frequency trading, I'm happy to have a discussion afterwards. That's where I come from. I've been working there for 20 years. In this world, it's about nanosecond, it's about FPGA, and it's all about being faster than the others. If you don't know it and you want to know more about it, I recommend a book by Michael Lewis, Flash Boys, for those who have not read it. It's really interesting to see the dynamics of high-frequency trading and how these guys make money without taking risk. So just to give you examples, just to win 3 milliseconds between Chicago and New York, high-frequency traders actually built a dedicated fiber between the two cities. That was in the 2003-04. And then a few years later, they realized that air was faster than fiber. So was built some radio waves from Chicago to London, from Chicago to New York, and currently some projects are going on in Europe to do the same, just to win another 2-3 milliseconds. So this is not what we're going to talk about here. Even though, in this case, time is money, actually. A study was made in 2009 showing that by shaving off 5 milliseconds, a broker could actually win 4 million a year. So it's a lot of money, just with those milliseconds. For different reasons, in the retail trading population, so when I say retail trading, that includes asset management as well, this can be applied because of information asymmetry. So who's familiar with information asymmetry? Yeah? All right. So information asymmetry was well covered in 2001 when a Nobel Prize was attributed to the guys who put a theory around it. It's pretty simple, just to say that if I have any information and you do not have that information and you think we're on the same page in terms of information and you make a decision, I'm a winner and you're a loser. So it's also called the lemons trade. So when a car seller sells you a car, he knows way more about the car than you do. So he can sell you things that you would not accept, but you don't know about the car. That's information asymmetry. So what's going on right now in capital markets and investment is that in some instances there is information asymmetry between a retail person receiving data on news 15 seconds after another, and the market has changed. So what the web is bringing to this is the possibility for everybody to have the same information at the same time. The web was created for transparency from the beginning by Berners-Lee at CERN. Then Fielding also with APIs, so I have to mention Fielding, wanted the web to be as transparent as possible and to allow for transparency. So the web is the best tool possible to fight information asymmetry. So here I'm quoting another study that you cannot read, but I encourage you to have a look at it, from Saxton and Sunny from 2013. And what he did is he looked at information asymmetry between insider information and outsider information and tried to correlate whether there was more or less information asymmetry on stocks that were heavily covered on blogs. And the result is that there is a direct correlation between how many bloggers are covering a stock and the lack of information asymmetry. Actually, it looks like financial analysts have less impact than financial bloggers, because financial bloggers tend to have information that's way closer to insider information. So on this one, and a good example is stock tweets today. Who knows stock tweets? All right, it's pretty cool application for sharing ideas, opinions on trades. They actually embedded the dollar sign before the ticker symbols. And this is the kind of tool that the web is bringing to capital markets that are live now and really transforming some market inefficiencies through real time. Now let's talk about real-time UX and how you make money out of it. So we covered before HFT, how they make money out of it. It's just you're faster. Now, in terms of real-time user experience, how do you make money if you're real-time versus not? Well, the first thing is that if your application that is used by your users is real-time, it corresponds to what our brain enjoys. Our brain can compute images in 40 milliseconds and actually can react to an event in 500 milliseconds. If you have an application that needs to be refreshed, then you kill the emotional link between you and the content of the application. So if you have an application that shows you something that happens on a very frequently, then what's going to happen is that your application is more engaging. So your customers are happier and they want to trade or use your application more. So if we look at e-commerce, Amazon found that there was a direct correlation between their application latency and their sales. And Google, on their side, found also a direct correlation between the time it takes to make a search and the generation of traffic. So it's not like a good thing to have. It's really it's real money that you can make by providing real-time information to your end users at the end. So that was the philosophical economics covering. Now, what we're going to do is to look at real-time API and real-time UX and how you build it. And first of all, I want to, as a conclusion, I want to talk about the constraint that you're going to face when wanting to build a real-time application and make your APIs real-time. The first thing is that you need to be careful and grateful and cognizant of your users that end up being developers. So it's all about the developer experience. You want to give them a good experience. You don't want them to have to fight to be able to use your content, because you want to have a developer community working your API. So that means that there are formats that some of you may know, like fix, itch, fast, those stuff. Who knows those names? Yeah. All right. So these are protocols, pretty cool, and they were built for algorithmic trading. But they are not protocols that are known or used by developers of applications. So you're going to have to adapt and actually go with standards. We're big fans of standards. For many reasons that we'll cover later. So it's going to have to be HTTP. Also, the other thing is that it has to be scalable. You're not talking 1,000 or 10,000 users. You're talking millions. So the choices you make have to be scalable right from the beginning. The other thing that differs from the usual capital markets environment is that you have to put a service that works well, not only with wired desktops and web, but also on mobile applications, on tablets or mobiles. And that's a very strong constraint in terms of bandwidth and performance. And if you want to capture and stay in the recommendation of the brain of the users, you have to target 500 milliseconds for any interaction. So that's another constraint. You can't have a lagging application, even if you have millions of users at the same time. So for this, we're going to see how we do it with Allan.
Okay. Thank you. Can you hear me? Yeah. So, well, the problem, the main problem is scalability, because the main problem is our best friend, HTTP. It was not built for exchanging real-time information. At the origin, it was just to get basic and static pages. So the protocol itself that is still running the web is not well designed for this kind of real-time application. And as you see, because it's also rely on some stateless infrastructure, meaning that each time a client needs to request a resource on the server, he has to repass again all the information that will help the server to understand the context. That generates a lot of information back and forth, and that was the main issue. But as nature is well done, we find always workaround. And the first workaround that we found is what we call long polling, meaning that a client that needs to request something from the server will perform his request, and if the server doesn't have to tell anything to the client, we'll hold the connection open until something has to be sent. So it's hack. It can works for, I would say, desktop application with a large amount of bandwidth, but now that we are getting into the smartphone area, and that the network protocol and mobile network protocol are pretty much difficult to have this kind of techniques. So I invite you to get back to the future, which is today. A small reminder: it will be 21st of October. So for the geeky people, don't forget to welcome Marty McFly. He will be there, I'm sure. So there is, we will see two techniques that can be used. The first one is server send events. Small question, who knows server send events? Great, you're here to learn. Server send events is a standard which is natively implemented in web browser today. So if someone wants to use this technique, it doesn't have to install anything. It's already implemented in the browser. It's not well known, but it gets to be known because it's fully HTTP compliant. So meaning that it relies on HTTP. It enables a server to push information directly to the client without the need for the client to periodically request the different information, and it's defined by the W3C, so it's part of standard of HTML5. And the second solution is WebSocket. So maybe this one is maybe more known. 1, 2, yeah. Okay, and we will see the difference between the two. It's also a W3C standard. It has some benefits and some drawbacks compared to server send event that we will see. So if we compare the two, when we have a server send event or WebSocket compared to other techniques, when the server connects to the client connects to the server, it initiates a channel that will last forever compared to long polling. So meaning that once you have established a connection, the server can send an information at any time, and you don't have to repass all this header information that are very verbose on HTTP. So you get the benefits from HTTP because it's based on HTTP, but you don't have the drawbacks of having to repass all this verbose information, and you can make your application real time. The main difference between WebSocket and server send events are the fact that WebSocket uses HTTP as an initial request to upgrade to a WebSocket protocol. So meaning that the developer, when he uses WebSocket, he only has a socket. So he doesn't have anything more than a socket. So he has to redefine all the protocol, the exchange, so the request response, the format of the message. But the benefit is that WebSocket is bidirectional, meaning that when you have established this link with the server can push to the client, but the client can also make some requests to the server. So it's really bidirectional, which is not the case for server send event, where you still rely on HTTP, but you can only send message from the server to the client. But for use cases such as applications that display quotes, so coming from the server, that's good enough. And it's easier to use HTTP for existing web infrastructure because as WebSocket is not completely implemented in some proxies, you may have some potential problem when you want to use WebSocket in existing web infrastructure. From a developer point of view, it's I would say more difficult to develop because, as I told you, you only have a socket, so you have to re-implement all the error message handling, all the request response handling, compared to SSE, so server send event, which is based on HTTP and more right away to use. Then in terms of networks, load network, both are well better than long polling, because of course you don't have to resend the information all the time. The server sends the information as soon as it's available. And from app latency perspective, we'll see some benchmark as proof is in the pudding. So if you compare a streaming application versus an application using standard HTTP REST, so the use case is that the application will post some information to the client. So the idea is to move two different metrics. It's the number of message and the payload of the message. And as you can see, you can get really fast in trouble when you're using HTTP REST, because if we take the last benchmark for 5,000 messages of 1 megabyte, if you're using streaming protocols such as server-side event or WebSocket, you can exchange this amount of message in 1 second, a little bit more, while with basic HTTP REST, because of all these variable things that you have to repass all the time, you're far away from this 500 milliseconds that the brain needs for keeping emotion with the application. So that's streaming versus HTTP. And if we compare the two streaming technology, which is server-side event and WebSocket, well, that's kind of surprising. This information are coming from a person that developed a Twitter client application. He first developed the first version using WebSocket, then he found out that server-side event was cool, so he tried it also. And he made this little comparison with the different browser, and you have a lot of difference in terms of performance just for downloaded 500 tweets. So maybe that will be better in the future, but server-side event wins for that. Now let's get our hand dirty a little bit. I have 3 minutes. Okay. Not easy. The idea is to show you how to develop a JavaScript application, could be mobile or desktop anyway, using our service, which is Stream Data. Maybe we'll have a couple minutes to discuss about it. But basically is that we will take an API from one of our favorite partner, which is Ignite, stream this API using server-side events, and animate the UI to show you how we can do cool stuff from a UI point of view when you get this real-time updates. And we will be using, for the developers, a new JavaScript framework named Riot.js, which will enable us to build some event-driven application. Do you see the code? I know it's maybe hard just after lunch to get all this code, but believe me, that will be okay. So the idea is to have this application event-driven, meaning that we will have a service in the application that will be in charge of fetching the data from Ignite. This service, once it gets its data, publish the data into a local bus of events, and then we will have a widget component that will listen to the bus, and each time there is a new data, it will refresh the UI and animate the UI for user experience. So that's pretty simple. I'll show you the component in charge of fetching the data from Ignite. So you just have to put a Ignite URL, our token, because we just authenticated the request. And basically, for developers, you have 3 callbacks. The first one is called when the first set of data is received by the application. So when you start to listen to a specific symbol, for example, you get a first snapshot of data. And as soon as a new data is available in Ignite API, you get patches, only things that change. So you apply the things. And when you get these patches, you publish in the bus of events. On the other side of the application, which is the UI, we have some, CSS, HTML things to display. But what is important is that we listen to the bus, and each time the bus has a new value, then we update the UI. So let's try to run it and see how it works. So I'm just launching a simple HTTP local server. and display, for example, Euro to USD. Just mount my component. I have 0 seconds, okay. Should have to work the first time then.
One chance.
One chance? Do you have networks?
Yeah.
I should have networks. Doesn't work. Okay. Try a second one. Sorry about that. It's demo effects. Anyway, we have.
Yeah.
Okay, you got it.
Whoa.
So just for people that wants more information, there is a blog post based on this application that define all the steps to build this application, and to the blog post, and all the source code is available on GitHub. So you will have the link in the presentation. Okay, hope you like the small code session. Change a little bit.
We have time for one question. Thank you. So I like the real-time talk with real-time debugging and real-time work. Really good. One question. There, yeah, one question on the back. Make me run.
Hi, it's an impressive demo. Is it not all a bit dependent on how fast Ignite gets the data, though?
So our service, what is not well defined, is that our service running in the cloud will fetch data from Ignite. So as a developer, we provide a web portal where you can define the polling frequency that you want to apply on each of your URL. So meaning, for example, you want really fast data, so you will set, for example, 1 second polling frequency to Ignite. And for news, where you know that 10 seconds will be enough, then you can set up a different polling frequency.
Thank you very much. Thank you. So if you want to know more, like it's stream data, there you have some information there about what they do. But thank you very much for the talk. Thank you. Some applause.